Okay, so alaikum. So let's get started. What I'm using as a prompt today is an IoT device that is a some kind of a tool for a satellite mapping company. Now let's get into some definitions. So what exactly is a satellite mapping company? So we're going to do some brainstorming. So this is a company that has some hardware. Oh, this is a little too big. Let's reduce the icon a little touch. Oh, that's a little too small. Let's make this. How about in the middle? So hardware. So it's a type of device. Um, we are talking about something. It's also do the rotation. There we go. So much better. We're looking for space tech. So what tech means is some sort of electric device. Since we have no assumptions, we always want to look at everything. We're looking for something that's secure because security is very important. It is, as the name implies, an internet based item. So there's definitely connectivity. There's communication. So that all means communication, comms, connectivity. So that's connection there as well. When we talk about space, we're talking about something that's also again, there's a communication part of it there, but it means it is expensive, as it is not cheap. Send things into space, and communicating between what's out there and down here is important. So that also means it may have some commercial value, as the name implies. That means it is used for selling images, selling content. So that's sales of content. That's R&D. There's research being done. There's a lot of recording. So things have to be safe. There has to be a lot of backup, backup slash redundancy. So those are some important emotions, right? When we talk about hardware, backup, and redundancy, those are key things that come up. So hardware itself has to be reliable, dependable, and in some ways easy to maintain. So it's also maintainable. Since this is a commercial item, so the intersection between that and the hardware branch would be it's also affordable, right? We can't have a company we can't have a company that produces something but is not able to make money off of its side. So there has to be affordability. So when we're talking about something that's built and how it's built and the costs of a cost of production, they have to be uh, efficient, efficient, effective, which basically means trim off excess fat. Okay, so let's kind of take a let's take our satellite and move away from this and take a look at the big picture here. So the big picture is that we're trying to build some kind of a device that is used as an IoT device. So when we think of an IoT device in this type of context, uh, we typically gravitate towards things that are handheld or things that are relatively smaller and we can relate to. They are close enough that in proximity to other devices, the Internet of Things, that they're able to communicate and converse with and create essentially a network. So let's think of that. Let's think of it as a handheld device. So I was collecting a mood board of sorts and getting a sense of what this type of device may be. So let's look at the emotions around it. We want something that conveys information, that shows the data that's been gathered, that shows information that is being collected. It visualizes things. It is very graphical for something that is mapping. Mapping in general creates this network of information, these connections that are joining. You start off with a blank canvas or darkness, and then by adding more data, by adding more information, by adding those images top down, we're able to create these visualizations of the reality is. So that is a very important emotion that has to be conveyed, which means that our device needs some sort of some sort of display, right? So we want that information to be displayed. So it has to be showed, right? It cannot be a box that doesn't show anything. It needs to be able to signify that something has been gathered. It has to indicate. It needs some form of an interface that allows those types of actions. Let's look at product communities. So product communities is a term to me which basically means that when we look at everything across the spectrum of what's out there, what has been produced, what has been manufactured, and if I create communities based on either what they look like, either how they're used, where they're typically used. So if we create a network, right? So if we create a network of where in the world, geographically speaking, would we find our IoT device that is used for this? And what are the other products in that community? So, to me, I understand that this would be a handheld device. It would be a very recognizable device that anyone who's part of that company, who's part of that team, who looks at it understands what it's supposed to do. So there's that recognition and trainability that goes to it. It should be fairly utilitarian because its purpose is to convey information, gather information for a commercial, and it has to be very functional. Right? There's not as much of an emotional connection that a person builds. There's not as much of a downtime interaction that a person has with it. It's a very active device. It has to be very utilitarian. So looking at these things across the board, this is sort of what that person who's out there in the field might be carrying, or people out there in the field around this person might be carrying. So these are those product communities that we're trying to build. In terms of materials, the most important thing is reliability, dependability, robustness, and something that is going to last in the field for a long time. So it's an investment that the company is making. So it's an investment that has to last. It is protecting valuable tech. So this device is certainly containing this enclosure for devices containing some kind of electronics, or some high fidelity sensors. There are some high power antennas. There's information being gathered. There's some memory at some point, which is buffering all this data that's being collected. So it's a very volatile state, right? So you want to protect that. You don't want that information lost. You don't want that information just essentially lost in the field, where an accident or some kind of an interception or damage causes that problem. So you want it to be very robust, very dependable, very reliable. So materials have to reflect that. So in terms of the actual enclosure, in terms of the actual build, using something that's durable, it's in the form of metal or hard plastic, um, and affordable metals as well in this case, is important. Anything that's touch, so uh, touch surfaces or interfaces, as we call it here, they have to be they have to be interfaces that reduce risk of accidents, that reduce risks of things being dropped, or things being lost, or things being slipped out of hand. So that is a fairly utilitarian idea for what this type of product would look like. So now that we have a general sense of what the big keywords are, what the big functionality is for this, let's get down to what we think it might look like. So I'm going to reduce the opacity of some of those layers, and I'm also going to use my fill tool. I appreciate using this, and I'm going to reduce the opacity of this to around 70% or so. The reason for this is it's always nice to build things in blocks. You take clay, you take Play-Doh, and you're essentially putting Play-Doh together and you're trying to create some form and some value. So here's this device which, let's say, has some kind of an antenna. This is There are some buttons around it as well. So you're using these as ways to create general silhouettes, right? So let's say this is some kind of an antenna that goes around here. There's some buttons over there as well. Um, there may have there may be some kind of screen, but the screen at the top has to be protected in some ways. So let's do that, and let's add some more. Add some more data. So let's do this. Let's use a nice dark black color to add more structure to this here. So I'm going to turn smoothing down a little bit. Let's turn it down to around 2%. So this is some some iteration of what this looks like. Here's our antenna, which is a fairly long range antenna of some kind. I'm assuming that the antenna needs to be protected, and perhaps the antenna has an extendable portion as well that allows it to grow in size as needed. Depending on what type of communication protocol this uses, perhaps this antenna has a certain structure or a certain size that it must have for the data that it's collecting to be reliably received, right? For the signal strength to be appropriate. So let's put some control knobs in there. Let's put some knobs over here. So let's say we have one knob for general scrolling and selecting items. We can have a button in here for some interface. So let me use another color for that for the time being. I'm just going to stick with whites and blacks as neutral values to deal with this. So let's say you have some kind of a button in there, and then on the top you have some kind of screen that goes up around this area. So we're essentially creating a general packaging of what these parts are in this device, right? So we're creating what is actually housed in this device when this is being used. We're creating a think of it this way. Those diagrams from biology class where you're okay. This is where the lungs go. This is where the hearts go. So that's essentially what we're trying to do here. We're trying to place objects inside. So we have our screen over here. We're placing our antenna, which might, depending on what type of coil it is, looks like that. Now, for those of you who are familiar with, oh, my battery died with PCB design and production design in general, industrial design in general, you're familiar that we'd like to try and keep PCBs relatively simple, right? We don't want our product to have multiple PCBs if possible. So let's say the biggest plane that we have is around here, and if this is a a knob in this area, then maybe this is where we place our PCB, right? So this is our printed circuit board, display right over here, and our display is mounted onto this PCB. This is our high speed antenna. That's our knob. There may be some kind of a charging port down here that's connected. So there may be a USB-C or some other proprietary charging port that's used. That's our knob control over here. There's a button over there as well. And let's say that we do need some other protected source, some other protected button. So I'm going to add two other functionality, two of the buttons over there. So this is essentially the structure of our device, right? This is the the packaging of the contents inside it. So once we have this, we can then get fairly creative. We don't need to limit ourselves to let me use another color here. We don't need to limit ourselves to this specific packaging, right? We can move things around. So one of the things I like to do here is let me just take this as a second and then try and see. Okay, if I'm placing an antenna there, can I place an antenna sideways? Does that help the device if I reduce the form factor a little bit by placing the antenna in a different format? So let's try doing that. So I'm going to duplicate this layer here. And I'm going to try and move things around. It's essentially like working with Play-Doh, right? So you take an object out and then you move it to another location, and then you try and see if that location that you've picked helps in some way. So an antenna in this case, I suppose, right? So if you have your information being transmitted from your That's your satellite over there. And so that's transmitting data. Perhaps your antenna needs a certain amount of clearance. And maybe this idea doesn't work because it doesn't afford you that clearance around it, right? So this might only work if this device was, so that's your satellite pointing down. This might only work if the device was pointing to the satellite like that, if the antenna was pointing up. But maybe if the antenna was pointing that way, you may not get a good signal. So perhaps this is a bad idea for that reason. So these things are important. This would mean we would have to have another antenna and we can't afford it. So that means our device has to kind of look much like this GPS device, right? So this Garmin GPS map in some ways. We want a top facing antenna. Perhaps we want the antenna to have some form of rotation. So we want the antenna to be able to rotate. So let's put this over here. Let's take this diagram. So let's take this down. So perhaps we want the antenna to be able to rotate up and down and swivel, right? Swivel depending on which which way the person is pointing the device and which way they're reading it. We want the device to be able to go up and down. So that means that there has to be some kind of a hinge that we are using in this case. So maybe the device is, the antenna is hinged. In this case over here, that sounds like a reasonable idea. Like our product is slowly coming to form. So we have a few touch points, right? So we have an antenna over there, we have a knob over here. So let's think about it. We have an antenna that can hinge. What else can we do with that? Let's see. So let's take this form. Let's iterate a little bit more here. Let's remove this. Let's remove so let's take this as well. So let's say if I turn the antenna all the way down so it's closed right there. If I turn the antenna all the way from here down this way, now my device is a lot more compact. Well, maybe that helps with storage. Maybe that is a good form factor for us to be able to take this device, package it, protect the antenna, so no one's going to push it from this side or the other side and break it accidentally. Maybe the antenna form itself, and let's use another color for this. Uh, Maybe the antenna form itself is such that it allows us to let's go down here. So maybe the antenna form, because this is a we have a knob over here and then an antenna over here. So when this thing folds in to get it flush with that knob, maybe the antenna is has a cutout on it. Maybe there's a cutout feature that actually protects the knob, so it has a two-in-one functionality, right? So the antenna, when it's fully out in this position, has this profile where it protects the knob when it's being used in the stored position. So our device is slowly coming to life. Let's say we use our client has specified that this needs to be an LCD display. There's a square LCD display that we're going to use here. There's going to be some a couple function buttons over there. Maybe we place the function buttons in here so we can, and we're recessing them so they are protected by the antenna when the device is closed. So recess buttons. So that is done to protect those buttons when the device is not being used. And let's say we've made the decision that, and let me use another color for this. We've made the decision that we're going to have some kind of ruggedized grip on protecting these top and bottom materials, right? So this way, when someone holds it in hand, it's going to be it's going to be nice and secure. It's not going to be easy to drop and easy to slip. Likewise, when we have this display that pops out here, we're going to have lots of a big nice bezel that protects the display. So if someone were to drop it on a rock or drop it while they're out in the field or place it in a bag, they don't have to worry about scratching or damaging the screen. So this looks like we have some type of a form that's evolving. So let's take this. I'm going to copy this down here and create essentially a new layer. I'm going to try and see what it looks like when I flip it, right? And try and observe what different layouts might be, how it's held, and just see what that looks like. It's always nice to observe and turn sideways and see if there's a different kind of form that evolves or a different kind of layout that comes out. So we're going to merge these layers down, and then we're going to reduce the opacity of this layer just a touch, because we want to be able to observe and create a new line on top of this. I'm going to lock this bottom layer, and I'm going to take these. Let's just use this tool. Let's use the pen tool in my case, which is a sort of an oil-based pen in this situation. So let's create some nice smooth lines. So I like this. I like this form with nice rectilinear surfaces. They're they're very reminiscent of handheld ruggedized devices, similar to the Pelican case I had at the start itself. I'm going to create a grid here just to be able to create nice vertical lines and nice and straight lines in this situation. So let's do that. And let's create our antenna. And this is the antenna design that we're going to go with. And since we need to protect our knob, our button, we're going to make sure that our antenna extends down enough that it does this functionality of protecting the actual button. So that seems like one reasonable format for our device, right? This is a handheld device right there. Let's get this done. Let's get these items done. And we're going to create some nice textures around here. And then once we're done with this, we're going to take this down into Viscom and work through our AI workflow and see what that might look like. So here's one form, which is this type of display, which is a square, fairly typical idea, right, of what a handheld type device might look like. Let's add a little bit more structure to this, and let's some shadows and work with uh, some details so we can actually see and visualize this better and see what this would look like in our situation. So that's what our product is. I like the personally, I'm a huge fan of the marker tool. When I was training in design, I came from that generation where we were still fairly heavily using markers as a tool, and I was hooked. I was a big fan of Prismacolors back when uh, they were still being sold by Michaels here in Canada, and now for some reason they've stopped doing that. But I like it's a good callback to the nice days of analog design tools, and it's there's something about it in it's very nostalgic in some ways too. So I certainly appreciate and enjoy every opportunity I can get my hands on something that's more old fashioned. So that's an idea for some type of display. Let's look at some other poems. And now we have a general sense of what these what this type of device needs to look like. Let's look at some interesting ideas that are sort of uh, less like what we've been doing right now, right? So we've been looking at more rectilinear forms, very rugged, old-fashioned uh, types of devices. But how can we make this even better? What can we do here that creates a type of a product that's much different than what we've been building so far. So what about a device like this, right? So what about a device? It doesn't need to look angry. What I call this device is an angry device. Does this device need to look angry? Perhaps it doesn't, right? We said at the start we don't need to create an emotional connection to our product, but that not creating an emotional connection to a product doesn't mean that the product needs to be cold, right? Doesn't mean that the product needs to look uh, menacing or boring or sharp. Uh, it's it's well proven that the tools we use to do things and work, they affect our mood, they affect how we feel. So the effect of these things is far reaching, right? It goes well beyond just it goes well beyond just the act of working itself. They affect our day-to-day lives and our personal lives in many ways too. So what about something like this, right? In this case, I've created essentially a handle. So if I go and think of the tools that I had previously, right? So let's use this green color as a for the time being. I can still have my antenna up there. That can still be my antenna. I still have a nice flat PCB. As you already saw, my knob is right around here and it's actually protected. I have two buttons in this case, and I have a display. And technically, those of you who are paying attention would say that, well, circular displays are more costly, they're harder to find. So this may still have to be a square display that is masked off with a circle. Very valid point. But look what I did with the housing. So by creating a housing this way, such that it was connected, I've created a handle. So this is now a handheld handheld device, which makes it a lot easier for people to hold it in the field. It's something that's less likely to slip off. So this is probably what this looks like. Let's look at the phone over here. That's the button. So, or rather, the knob. So this is what the knob looks like. So this is, in some ways, what the device would look like, and a person holding it would have their fingers coming in here, and so that's how they're holding the device up. So this makes it fairly robust in many ways. You can hang a carabiner naturally on it. There are no moving parts. This is naturally protecting the knob and the buttons from any kind of damage. So these are two interesting forms that we can use moving forward and creating some interesting concepts from. So this was part one of this video. In summary, what we started off with was a prompt for an IoT device for a satellite mapping company. We went through values and brainstormed what this product is going to be and how it's going to be used and what makes this product desirable and successful for the client, for the end user. We created a mood board using emotions around the use of this product, the product communities that are present where this is used, how this is used. And then we took a general look at materials and what those qualities are that we're looking for, that ensure that this is built in a way that fulfills the role and achieves the values that we've set forth with. We took that and we created a packaging of the components. So we laid out the internals in a very broad strokes format, and we created some forms around it and brainstormed some ideas of how certain things may be manipulated and used. We're very high level in this, and we only looked at the two ideas. The next time we come together, we'll take this process in a more fluid, in a real time format, work through a few ideas, and then we'll take those ideas, iterate them more using Viscom and other AI tools to create better, higher fidelity renders. The idea would be this is a workflow of how we create concepts that we can show to our clients and see what they feel, get their feedback, and iterate this product more and more. So I'm excited to join you next time. When we meet, we will go through the fun part of this exercise where there's less commentary and more work. As again, if there's any feedback, any ways we can make this process better, any questions, concerns, or comments, please feel free to share. And I look forward to seeing you all next time.